I am right now standing on the site of what we hope to be very shortly a dive hole. This is really the reason that we're here. This spot, we chose this from a collection of around 20 holes that we drilled throughout the lake to really narrow in on where our science question would be best addressed. So we chose this spot because we have specific variations in the mats at the bottom of the lake that we think will tell us a really interesting story about how they are growing in this particular environment. So we had one hole put in over there that showed us one type of mat. We had another hole put in over there that showed us the other type of mat that we're interested in. So this is a really key transition that we're standing over. And we chose this site in particular because our tether when we're diving is only 65 meters long. So we want to be able to reach our site of interest on either side and everything that transitions in between from one spot. So this is a pretty big moment to have this site and start putting in the hole. Looking forward to diving into it and hopefully not too much longer here.
And we're getting ready to send a couple of divers down into Lake Joyce. And I wanted to explain to you how that's possible. So the ice here is about 4 meters thick, and we needed to melt a hole through the ice, which isn't a situation you run into every day. So people here down in Antarctica have invented this device called a hot seat, which used to be a steam cleaner, but now it heats glycol, which is a type of antifreeze. And we have another device called a hot fingers, and it's basically a spool of coils, metal coils. And the glycol that's heated by the hot seat flows through the coils, but can't get out of the coils. And we put these coils in a big tube down into our dive hole, which is over this way. And the dive hole started out as a 5-inch drill hole in the ice. And you can see now over here, with a little bit of editing, the dive hole is now about 4 feet across, big enough for our divers to get in and out of. We've got a little walkway for them to get to and from their tent over here, which is where they're getting into their dry suits. The lake water temperature is around 0 degrees Celsius, 1 degree Celsius, so just above freezing, so they need the dry suits to help keep them warm. Right here in front of me is what we call the tether, and this tether hooks up to the back of the mask of the diver, and the 3 different lines of the tether allow for airflow and also keep the tether buoyant so that it floats up above the bottom of the lake and follows the diver around. It also allows for communication with our diver because we only send one diver down at a time. Our second diver will be up here on the surface monitoring oxygen flow and communications, and if there's an emergency, that second diver can go into the water as well and help out the first diver. And over here we have a communications box with a microphone. This is how we communicate with the diver under the surface, and they can let us know what they're seeing and whether they need more of the tether. The tether, I should say, is about 65 meters long, so they can go 65 meters in any direction from this dive hole, and that should allow them to investigate the microbial communities that are underneath us in the lake.
Things about life under ice is that it's very dark, but it's not constantly dark. It varies with location and with depth. So this device here is a light meter, and what we're going to do is go down and zoom a series of transects along depth contours in the lake and measure how much light gets to the microbial mats in different locations. And what we're interested in is how variable it is and how deep that variability goes. So the critical question is how much light do they get, but also how variable is it at a given depth. So in a normal lake or a normal ocean, then it's pretty constant along any depth contour, but because what this ice looks really different, there's white ice, there's blue ice, there's a lot of dirt in the ice, it really changes the percent of the incident light that gets through. can be tenfold difference, and so that's what we're after.
Okay. Okay, so we're still here at our dive site, and I wanted to show you a few things about what we're doing today in particular. So as a little background information, if you look out this way on the kind of on the slope headed down towards the lake, you can see some evidence of seasonal streams. So when it gets warm enough, the ice up above us in glaciers will flow down through those seasonal streams carrying sediment with it. And we're really curious about how that sedimentation will affect the morphology or shapes of the microbial mats that are growing on the bottom of the lakes. So to measure the amount of sediment coming into the lakes, Tyler, our geologist and lead scientist here, has invented some sediment traps. And here's one of the sediment traps that has basically a PVC tube that's going to capture all of the sediment that falls in the lake in this spot where the sediment trap is deployed. So the sediment trap will collect sediment through here. It's got this jacket of buoys around the outside to hold it up in the water column. And it's got a release valve that you can't really see down here at the bottom to release the materials that fall into it over the course of the year. So we're going to be placing these in the lake within the next couple of weeks. And today we are at our dive site because we have a nice 4-foot hole to practice our deployment of the sediment traps. And so we're going to make sure they are set up properly by dropping them through this PVC casing here. It'll be down in the dive hole there. And alongside the PVC casing, we're going to be lowering a drop camera so that we'll be able to watch the deployment of the traps and make sure that nothing is going wrong with them today.
Check. Okay. Take 2.